This video is about angle bisectors in triangles. So we want to start by discovering the definition of an angle bisector. Here drawn on this picture I have the angle ABC, and I want to cut the angle in half. So the angle is that space in there at B in between the two sides of this angle. And I want to cut that space in half by dragging this segment in and making it split the angle right in half. To indicate that an angle has been bisected, we want to show that the angles formed on either side of that bisector are congruent. So we would put a single arc here and a single arc here to show that we just cut the angle in half. So this segment that I just dragged down would be called the bisector of angle ABC because it splits angle ABC in half. And it can be a segment, a line, a ray, it doesn't have a specific length, as long as it cuts the angle into two congruent pieces. There's a special property of angle bisectors. I'm going to construct a bisector here. I'm just sketching, so it might not be perfect. I'm going to sketch the angle bisector of ABC here, showing that it's equal on both sides. Any point that's on the angle bisector I just drew, so let's say I put a point right here, is equidistant from the sides of the angle. So anywhere that you put the point, maybe I'll call it D. If you go directly from that D straight to either side of this angle by forming a perpendicular line with it, so the fastest way to there would be to create the perpendicular segment that connects it. Those two segments are going to be the same length as each other. So it's equal distant from either side of the angle. We're going to use that property. Let's say here it wants us to find the length of Rm. So I can see that I have an angle being bisected by looking down here in this corner, which means that any point on the bisector, like R right here, is going to be equidistant from either side. So that distance will be the same as this distance, which means the 7x in this picture is equal to 2x plus 25, and I can use that to solve for x. So 5x equals 25 and x equals 5. And then we're going to use that x value to find the length of Rm. Since Rm is equal to 7x, I can plug in the value 5 and figure out that Rm is equal to 35. Remember, when you write Rm with no symbol above it, that means the length of. You may already know this definition, but when you have three or more lines that all intersect at a point, those lines are called concurrent, and the place where they intersect is called a point of concurrency. So it's a special name for this intersection point called the point of concurrency. We're going to put some of the concepts together that we just talked about by sketching the angle bisectors of each angle in this triangle, and we're going to determine if those three lines that we make are concurrent with each other. So I have three angles here: the green angle, the blue angle, and the red angle. And I'm going to split each of those angles in half with a bisector. I'm going to start by just doing a little starter segment, and then we'll connect them and extend them after we've started it. So to cut this green guy in half, it's approximately there, and I'm not using rulers or measuring tools, so this is all approximate. I'm going to cut the blue angle in half, and that'll be approximately there. And I want to cut the red angle in half, and that'll be approximately there. So here are my three starter segments. It would be easier if I was using a ruler and actually had measuring tools, but I'm going to do the best I can here. I hope that it works out. I'm supposed to extend these segments. And if you're on paper, you should absolutely use a ruler. And see if they are concurrent. And sure enough, if you're doing it neatly enough, you'll see that the three angle bisectors we just created all meet at a point somewhere here in the middle of the triangle, which we can call a point of concurrency. This one also has a special name. The angle bisectors of a triangle are concurrent at a point equidistant from the sides of the triangle, and it's called the incenter of the triangle. So it has a special name called the incenter of the triangle. So when you bisect the three corners, like this one, and this one, and this one, so each of the corners has been bisected, and you draw those segments, they do connect all at a point somewhere in the middle of the triangle called the incenter. That incenter is equidistant from the three sides of the triangle, which I didn't show on the previous example, but it's shown pretty clearly here. That if you go straight from P out to either side of any side of the triangle, the fastest way to get there, which of course is the perpendicular one, you'll have three segments that are all the same length to get from P to any side of the triangle. A further special property is that if you were to use a compass, which is that geometry tool that makes a perfect circle, if you put the pin at P and your pencil at X, Y, or Z, because those are all three the same, if you make a circle, The radius of the circle is the same all the way around it. So you'd get this circle, which mine is very lumpy here, but this circle that goes through X, goes through Y, goes through Z, and has P at the center. So it's the circle that fits perfectly inside of a triangle, has P at the center. And we're going to use the angle bisector properties here. Nothing's labeled on the picture, so I want to start by doing that. I see that I have 3 angles being bisected in the 3 corners, which means I know that I have 3 lengths that are congruent. I'm going to label something on the picture that's given in the question. So GE is 2x minus 7, and GF is x plus 4. And from what I just showed on the picture, I know that GE and GF are the same length. So I can say 2x minus 7 equals x plus 4 in this picture, and then use that equation to solve for x. But it wants me to answer the question, what is GD? Well, GD is going to be the same length as, GF and GE. So if you just find one of them, like let's say we found GF. If GF is x plus 4, and we just figured out that x is 11, then GF is 15, which means so is GD. So the length of GD equals 15. And that is all.